Hi everyone, my name is Andrew Mallett and welcome to my course, Mastering BASH and Z Shell Scripting Syntax. Now I'm a Linux trainer and consultant working within my own company, the Urban Penguin within the UK. I've designed this course to give you the skills needed in developing your skills in understanding syntax and keywords used in modern Linux shells, those like BASH and ZSH. As you progress through this course, you're going to gain greater understanding of using things like variables and how to use the declare command. Of course, you're going to learn how to write different conditional statements before moving on to the ever amazing looping structures. Some of the major topics that we cover include converting case using the command declare. We'll be looking at the for each loop within ZSH, as well as writing effective shell functions. By the end of this course, you're going to be able to write scripts that are both efficient and easily repurposed for other needs. The big takeaway, though, is to understand that you will look in detail at specific elements of scripting syntax that are so often used. Before beginning this course, you should be familiar with the Linux command line and, of course, executing commands. With this knowledge already in your arsenal, you will gain the most from this course and really extend your shell scripting abilities. Now, I really hope you're going to join me on this journey in learning the details that you've always wanted to know about shell syntax. Hello and welcome to this course from Pluralsight. My name is Andrew Mallett and I'm here to welcome you to the course Mastering BASH and Z Shell Scripting Syntax. And in this first module, we're going to take a look at what is it all about and working with the shell syntax. As I say, my name is Andrew Mallett and I've got the great pleasure of being your instructor throughout this course. As we go through, we're going to be looking at different topics, but if you need to contact me, you can contact me through the course discussion page or on Twitter at the Urban Penguin. As I say, we've got a lot to get through. As we start looking through the different modules, we're going to be investigating what do we actually need to get our lab set up. Of course, being able to see the slides is one thing, but being able to carry out these tasks at the command line is another. We'll then be moving on to working with variables, and we'll be working with both the BASH and the Z shell, the Z shell. Now, if you're not comfortable with having both shells, it doesn't really matter. Either shell will suffice. It's just you can do a little bit more with the Z shell, as you'll see. We'll look at how we can create conditional statements. Now, of course, they are with what we would expect with maybe if statements, but we can also create conditional statements directly on the command line by not using if statements at all. So we can start looking at how we can build these up in a range of different ways. Now, once we've started creating some code blocks, we can reuse these code blocks. Now, they might be in functions that we store in memory within our shell, so they get loaded within our login scripts, but we can also build functions into existing Z shell or BASH scripts so they can be recalled. Very often we might create a menu, and each item of a menu will actually call a function, so we can modularize our code, creating small chunks that we can execute when needed. And finally, we'll look at how we can start building loops, so iterating through code using looping constructs. And this is what we mean by our syntax, getting to learn how we write conditional statements, use variables, writing functions, and creating our loops and iterating over code blocks. Now, of course, we're looking at working with BASH and the Z or Z shell. Doesn't really matter which one that you use, but we'll be using both so you can see a good comparison. In the same way for you in your own labs, it might be a good example if you can install both the BASH shell and the Z shell. Very often BASH is a default shell in many Linux distributions, but usually the Z shell can be installed. When we look at our lab system, we'll be working with a single Ubuntu 18.04 system, but to be honest, any distribution or modern Linux distribution should suffice. You could also consider using a cloud instance, such as an AWS or Google Cloud system. We only need a single system, and we're going to be hosting that for our demonstrations inside of VirtualBox. Our virtual machine requirements are pretty minimal, really. As I say, we're using a minimal install of Ubuntu 18.04 server, so we're not using a graphical environment. We're working entirely at the shell. We're going to have 1 gig of RAM and just an 8 gig single disk. If you're working with a cloud-based system, then you'll need port 22 open, but that's very often the default when we're working with cloud-based systems. You need to be able to SSH into the system. And as we say, being able to work with both BASH and Z shell is an advantage. So having administrative access to the system so you can install Z shell if it's not currently installed is going to be a good point. Now, BASH has been around since 1989, so 1 year earlier than the Z shell. The Z shell was first released in 1990, so they're both a little bit mature now, so we should be able to get by on any of these, even within an enterprise environment. Now, when we're looking at scripting and writing our syntax examples, traditionally, I suppose we would think of script files, so .sh files where we create a script, and of course we can run that script multiple times. But to be honest, working directly at the command line, those same script syntax elements we can put directly at the command line, whether that's an if statement, whether it's a looping structure, or whether it's creating a function. We can create it directly from the command line. Scripts are great because they're repeatable, and that's really what we want. We don't want to do something once and then have to try and recreate it at another time. So they're great for repeatability and, of course, then the speed of not having to go back and redevelop it. A lot of the time, though, we're going to be working directly at the command line because it's great to show examples and get to using the syntax quickly and effectively directly at our shell prompt. Now, we don't want to get bogged down too much within our environment looking just purely at slides. You're not going to learn that way. So let's move directly out to our command line of our Ubuntu 18.04 server and see how we can ensure that we have ZSH installed and ready to go. Now, it really is fair that we don't shortchange you, so we promise you we're going to dive out to the command line and take a look at how we can install ZSH on our Ubuntu 18.04 system, so that's exactly what we're going to do. The package name, though, ZSH, is going to be the same no matter we're using Ubuntu or CentOS. So we can make sure that we're going to get some success straight away at the command line, and we're going to be able to move ahead with this course with the greatest of speed. Come on, let's find a command line. Now here we are, we've managed to find ourselves an amazing command line shell. Look at this, you can't get much better than this, can you? And remember, we're here to learn, but also have a great deal of fun as we go through. So please ensure that you have a good time too. Now the first thing is just to understand what we're doing. So if I go through and use the hostname CTL command, we can then go through and see, well, I am in fact using Ubuntu 18.04. We can see it's the .4 release. We're using it on x86 64-bit system, so we've got our system up and running. Just running the PS, the process status command, I can see then the shell that I'm currently running is the bash shell. Now, most things we can do within the bash shell, but there's some extra syntax elements that we can take a look at within the Z shell. But generally, we're going to have to install that. Let me go through and clear the screen. So that would be Control and L to clear the screen. Now we've got the screen cleared, we can go through and use sudo, and maybe we're going to use apt and take a look at searching. Remember, this is a regular expression that we search for, so I can go through and say, I only want to look for ZSH. So if I look for ZSH, so beginning with ZSH, but that's also going to be the end of the string to search. So now we're only looking for ZSH in the string. So we can see then that we're just getting the one package back. If I didn't put my regular expression elements around that, if I just search for the text ZSH, then I get a lot more coming back than we see with just the one package. So it's always worthwhile building in your searches at the command line to build in a regular expression as well if we're getting too much coming back. If we want to go through and take a look at some info on this, then I can go through and use apt and show and take a look then at our ZSH packet. We know now it's called ZSH. So we can see then a little bit of detail. Take a look at the description towards the bottom. So shell with lots of features. And we can see some of those enhancements. So ZSH most closely resembles the corn shell, the KSH, but it's got additional enhancements. So command line editing, built-in spelling correction, programmable command completion. So a lot of additional features can be added. So this is why we want to look at both BASH and ZSH. Let's clear the screen again. Now, so far we haven't installed it, so we better get around to doing it. That's what we're meant to be doing. So we can then go through and do an apt and install. So then as we go through, it's adding in ZSH common. It's suggesting we could add in the documentation as well, but at the moment we're just installing ZSH and ZSH common. If we were installing this on the CentOS system, we could do something similar, but of course it would be yum install. But let's go ahead and carry on with our install. Now that's really all there is to it. ZSH is now installed. To get it up and running, all we've got to do is just type our shell. We can see then that it comes up with this configuration. We can choose 0 at the moment, so we leave it with an empty configuration file, but we can always go through and rerun the function. It's shown there at the top of the screen, ZSH new user -install. But for the moment, we're not so much worried with the functionality of the shell, but with getting into the syntax elements. So I'm just going to choose 0. We'll leave it at a plain and empty configuration. But now typing PS, we can see then that I am running the ZSH shell inside of my bash shell. Ideally, though, of course, if we wanted to run ZSH, we'd run it as an independent shell and not part of another shell. But that's it. It's installed. Let's look at summarizing what we've looked at. Now look at how good you are. You've managed to get through this module. Okay, it was an introduction, but look how quickly you got through it. You're going to be well in your way of understanding the syntax of both BASH and ZSH. So we were looking at the fact that BASH and ZSH have a similar birth date. BASH was born in 1989, and a year later we saw the introduction of ZSH. They are both newer shells, but a little bit more function exists in ZSH. We had to install ZSH. Now to do this on our Ubuntu system is using apt install and ZSH, and of course then using yum if we're on CentOS or Red Hat based systems. Now we can use either shell, and we can work directly at the command line or within scripts. When we're working within scripts, they're great for repeatability of commands because, of course, then they can be run many times across different systems, and they're going to be both reliable and repeatably correct. But for quick testing, we're going to see that we can use the command line to quickly run through some demonstrations so we can start understanding what keywords are available in BASH and what keywords are available in ZSH, and the difference, let's say, between a for loop and a for each loop by being able to build it directly at the command line. So we're going to see a little bit of both, where we will be building some scripts, but a lot of the works are going to be demonstrations so you can see just what you can do with syntax at the command line of either BASH or ZSH. Anyway, that's the summary done. We're next going to be taking a look at how we can work with the variables and really get to understand the raw details of our variables and our different types of variables and variable scope. Come on, let's find the next module. Hello and welcome to this Pluralsight presentation. My name is Andrew Mallett and I'm delighted to welcome you to this module, working with variables. And yeah, we're going to go and understand a little bit more, and hopefully quite a lot more than you already know or think you know about variables. Variables are just one of those things with, oh yeah, we understand those. But there's an awful lot that you can do, especially when we start looking at the command declare. Now, we've got a lot to go through, so what exactly is on our menu? Well, we're going to be taking a look at our local variables, we'll be looking at environment variables, and we can also set variables within the command scope, so command variables. And this then gives us an understanding of how that variable works and the variable scope. We'll be taking a look at the declare command. We'll start this by taking a look at some of the very basics before looking at a few more things that we can do, such as creating integer variables, creating constants, and going through creating arrays. But once we've started with the declare, then as I say, we can start looking at constants, integers, and arrays, all of which can be done with that built-in command. Now, variables are just one of those things that we probably do think we understand, and we probably do understand reasonably well. Now, we can set a variable ordinarily, just setting the variable, and that's then local to the shell. We can set things called environment variables using the export command, and we can also set variables that are only effective for the one instance of the command. The local variables, when we look at the scope for this, we see that the scope is just the shell itself. So if we make sure that we've got the full version of Vim installed, we can then go through and set our editor variable. Now, our editor variable can control the editor that is used with certain commands. Those commands such as crontab will by default open up in Ubuntu using the nano text editor. The editor variable should be able to control it. But if we then go through and use the crontab -e command, we're going to find that it still opens up in nano even though the editor variable has been set. Well, that is because when we've set the editor variable, it's available to the shell, but not commands launched from the shell. So it's not effective where we need it to be. The scope isn't large enough. And that's where then environment variables come in. So we can then go through and export editor equals Vim. Once we've then exported it, it's available in our environment, it's available to the shell and commands launched from the shell. So now when we use crontab -e, it's going to open up in our Vim text editor. Now, if we don't want to set the variable permanently, we can set something that we can call a command variable. The variable now is only effective for the instance that this command is run. Only this command, and it doesn't persist after the command has completed. So we can see then that the command line starts off with the editor equals Vim setting the variable just before we run the command. So it's going to open up in Vim, but if we ran crontab -e after this without the editor variable, then it's going to open up in the default. So why don't we go through and take a look at the command line and start to understand this variable scope? So looking at the different behavior when we set local, environment, and command variables. So yes, we're going to start module 3 with our first demonstration. A demonstration we're going to understand a little bit about variable scope by taking a look at the local, environment, and command variables. Now, isn't this a gorgeous command line? We're at the command line of my Ubuntu 18.04 system, the system that we're going to be using throughout the course. And we're using a BASH shell, but you could equally be using the ZSH shell. It's not really going to make any differences with what we're looking at. Now, if I go through and take a look at the vim ---- version command, I can go through and see all of the options that are enabled in this version of Vim. And I'm looking specifically, I tend to look for plus syntax to see that I've got syntax highlighting. And we can see that I do. Now with that then up and running, it means that I've got a later version of Vim, or at least the enhanced version of Vim. We can check that if I go through and check to install Vim, we can see then that Vim is already installed, it's up and running. It's not just the tiny Vim, we've got a more complete version of Vim installed. So we want this to be able to work at the command line. Now, being a little bit familiar with Linux, we might be thinking, well, I like to use Vim as my text editor. But when we use commands like crontab, we can see then that we get a choice. Now, I can set my editor at this stage, but if I just hit enter to get in it quickly, I'm going to be setting nano. Now, that's said to be the easiest, so I might choose that and then decide, oh, actually, I'm not a big fan of nano. I don't want to use that. Now, we can rerun the select editor command, but if I just run the crontab command again, we can see that it doesn't rerun the select editor menu for me. But the best way to set the editor is by use of a variable. And this is where we first get to really understand our variable scope. If at the shell I just set a local variable, so it's local only to the shell, so I go editor equals vim, and then I look at crontab -e, I'm going to think, well, that was rubbish. It didn't do anything, so it doesn't work. But I need to make the variable available not only to the shell, but also to commands launched from it. Those commands such as crontab that we're trying to execute at the moment. So a local variable just does not cut the mustard. We need an environment variable. If I use the command set, we can go through and see pretty much everything that is in the shell, but we can't really get to see our detail without searching for the editor variable. So if I go through and we see, well, look, it is set. But when I look at the environment command, env, we can see the environment variables. Now, again, I might go through and prefer to search for it. So env and pipe it through to grep and editor. Now, when we look at this, we can see then that the editor variable is not available in the environment. The environment scope means that the variable is available to the shell and commands launched from it. We can then export our variable, so export editor. I could set it as well, but as it's already set, I can then go through and just export it. When we take a look now within our environment, we see that we've got the variable set within the environment. Now running crontab -e, look at this. Vim, we have success. So how good is that? But just understanding the difference between the local variable and our exported variables. So I took the variable and I exported it. We can then go through and unset, clear the variable. So if I use unset editor, now go back to crontab -e, crontab now falls back to using the default editor. Now let's just say for whatever reason I only needed to use vim for one instance of our command crontab. So it is possible. I don't want to permanently set the variable. So I can then go through and go to where the variable was set. And if I use then exclamation mark, we're going to repeat the previous command. Previous command, it's still on the screen there. It's crontab -e. So it's just a shortcut. But now we're prefacing our command directly with the variable. But it doesn't persist. It's just set on the command line and is only available for that command. Again, if I go back now, take a look at crontab -e, without prefacing it with the variable, we can see that it doesn't do anything other than open up in our nano editor. So we've seen that we can go through and set our variable within the shell. So that's great when the shell needs access to the variable. But if we need access to those variable values from commands, we need to make sure it's set within our environment scope, and we can do that with the export command. We can also, as we'll see later, use the declare command for that. If we only need the variable set for one instance of a command, then we can preface the command with the variable as we've seen. Now, one of the really useful tools that we've got available to us is the shell built-in declare, and it's a built-in command to both bash and ZSH. So that's really good. We don't need to differentiate between the shell that we're running. We can be running either of our shells. And this can be used to manage our variables far further than just looking at the tools that we've seen so far. Now, there's a lot that we can do with the declare command, but let's begin by looking at some of its simple usage to start seeing how this is a really good tool that we don't want to overlook. Now, one of the first things that we can do is start printing our variable values. Now, we can do this, as we've already seen in our previous demonstration, by making use of the set command or the env command. So if we want to look at our local variables, we can set our local variables. Here it's set to Pluralsight. We can then go through and search for that from the output of set. Now, if we have an environment variable, Pluralsight, the head office is in Utah, so we can then go through and configure that as maybe an environment variable. Here you can see that we're using the export command and then configuring the variable and value at the same time. We can go through and use the env command, and we can then go through and search using grep for the variable. So that's all well and good, but we're having to use set or env, and we're having to use it with grep. Whereas if we use the declare command, declare -p to print, if we just use that, it's going to print all of our variables. But if we go through and specify the variables that we want, so in this case it's myvar and myenv, then we only get to see those variables, and we can see by the configuration that displays whether or not they're local variables or whether they're environment variables. So all of the information is available to us through a far more simple procedure. But of course, we don't just set at being able to print our variables. We can even do simple things like converting case. So if I use declare -l when I'm configuring my variable, so fruit equals apple, and you can see in the value apple, we've used a mixed case. Well then, converting it through to lowercase, when I go through and take a look at the fruit variable, we can see then that it's apple in lowercase. Similarly, we can clear the variable, so unset fruit, declare -u for uppercase, fruit equals apple. Again, it's set in mixed case, but when we look at the stored value, it's been converted through to uppercase. So there might be reasons that we want a value stored totally in uppercase. It might be for days in the week. It's just the way that you want to be able to print it in your output. But imagine we could also be prompting for input for something like a username, and we're generally having our usernames in Linux as all lowercase. We can make sure we can build that into the variable itself, so we don't have to worry about converting the case through other commands such as the tr, the translate command. So again, it's saving us work. Now, I think we're getting on to demo time, aren't we? Now in this demonstration, we're going to drop out to the command line and get used to the declare command. Now I hope you can keep up. We're ready for demo number 2. But don't forget, when we're talking about keeping up, it is important that you run through yourselves on a console that you have open whilst you're watching this. Now that might be at the same time, or it might be played back afterwards. But also remember that you can both speed up and slow down the playback of these videos to ensure that it works best within your own learning environment and what suits you the very best. Not what suits us, it's what suits you. Anyway, sit down, relax, warm up those fingers, because we're about to dive into demonstration number 2, playing with this declare command. Now we saw before, when we were looking at our previous demonstration, that we can go through and set our variables and export our variables. So let's go through, we can go through and set it up in the same way. The variable doesn't exist at the moment, so editor equals vim. It's going to declare and set our variable. We can, as we've already seen, go through and use the set command to see this, but far better is the use of the declare command. Declare -p is going to print all of our variables, but we can go through and choose the variable or variables that we want. Here we want the editor variable. The options --, really saying that it's a local variable with no options that are set. So we can use the one command, declare -p, to see all of our different types of variables. But we don't have to just end here. We can go through and export our variables. So just using the -x will export our variable, and we can see that now when we go through and look at the declare -p, we see we've got the option -x, but perhaps more clearly, using the env command, we can print all of our environment variables, and just about in the middle there, we can see editor equals vim. So we can use declare for pretty much everything that we want. But again, this is not just where it ends. I can remove it from my environment using +x. So now when we see the -p, it's just declare --, back to being a plain old variable. And obviously we could back this up with the output of env, but believe me, or test it by yourself, env is not going to show the editor variable in the environment. So straight away we're already winning with our declare command. Far more functional than just the other sets of commands like set and env and export that we were looking at before. But we haven't even begun to start on the declare command. If we go back up, here we've got r plus x. But let's go through and set it as an environment variable again. But we can add in other options. We can add them as one lump, so minus xl, or minus x and minus l. Minus l is for lower case. When we go through and take a look, well, obviously we do have a lowercase value at the moment. It's all in Vim. But because most commands are going to be lowercase, it would be sensible, no matter the case that we type in, that we store the value all in lowercase, hence the minus L. We can go through and change our value. The variable already exists, so I can go straight into editor equals and then perhaps nano in mixed case. But when I go through and take a look with declare minus p, we can see that it's been stored all in lowercase. So this is absolutely amazing. I don't have to go out and rely on other commands like tr. So we've already seen straight away how we can start clawing benefits back from this declare command and hopefully giving you some enthusiasm about the importance that it is to learn. But we can go through and declare ordinary variables, we can go through and declare our environment variables with the minus x, and we can unexport them with the plus x. Importantly, we can always go and print out some minus p, just the values that we want from the variables that we want. And using minus u and minus l, we can convert the values to uppercase or lowercase, so giving us that consistency for display purposes or the way the value is going to be used. Now, something else that we need to think about is the use of the term variable. Variable means that the data can change. The reverse of that would be a constant, where once it's set, the variable or the data cannot change. So these are called constants. They're also known as read-only variables, which is kind of an oxymoron really when you think about it. Variable but read-only, so it's not variable. But commonly we call these constants. We can use then the declare minus r command, and we can go through then and perhaps set the name variable to equal Bob. If I try and set the name variable later and set it with a value of Fred, it's then telling me that it's a read-only variable. Once I've set the variable as read-only, I can't unset the variable and it remains consistent for that shell session. This might be useful for configuration that you want to set through a system login script and you don't want users to be able to change the value. Now, something else that we can make use of is declaring the data type, so setting it to an integer value. So I can go through and set declare minus I for integer, the days variable, and set it to a value of, let's say, 30. So here then we know that we have got a value of 3 and 0. If I try and set it, let's say, to Monday, then I'll end up having a value of 0 for days, because Monday, obviously the string, cannot be translated to an integer. So when I go through and take a look at it after we've set it for Monday, it comes back with a value of 0. So we could easily then go through and check for, let's say, a value between 1 and 30 being correct. But if we've got anything less than 1 or anything greater than 30, we could say that we've got an incorrect value that's been set. The variables that we've looked at so far are single valued or scalar valued. They have one single value. But we can also use arrays. Arrays are multi-valued variables, and these can be indexed, and it's a zero-based index, so the first value would be the 0 index, or associative arrays where we use key and value pairs. When we go through taking a look at it, we can then use declare minus lowercase a is setting up an indexed array. We can then go through and set it to user underscore name. We can then go through and set the values. So here we're setting index 0 to be Bob and index 1 to be Smith. As we then go through and try and use these values, it's going to be username 0, but then so we don't get confused, we put brace brackets around the username and the index value. We can then go through and unset our username and then use declare minus uppercase A to declare an associative array. With that done, we can then go through and have username equals and then first as our key and last as our key. We've got then Bob and Smith again as the values. To be able to see those values, same sort of thing before, but we use the key names rather than going through and using the index values. Now, I don't know about you, but I feel a demonstration coming on when we can then go through and work with our arrays, but we'll also be taking a look at our integers and constants. Now, we have got a little bit to go through in this demonstration. We'll be breaking it up. One of the things that we'll be looking at will be arrays, but we'll also be looking at our integers and constants. But to begin with, why don't we start by investigating the use of constants within our shell? Now, I think it's quite easy to forget what we mean by variables sometimes. If I go through and set, let's say, ansible_config, now we're not using Ansible on here, but it's a good variable to use because it really does make sense when we look at configuration constants. When I go through and put the value b to, let's say, etc / we'll just call it, say, hosts. It doesn't really matter. So we've got a value set, but of course when I go through and look at the declare for this, so declare and then -p for my Ansible configuration, I can use tab completion as well because of course it knows the list of variables that I have. So we can see then that's just a straightforward variable, and I could then go through and set it to something else where we could have it then, let's say, services. Now, if I wanted to enforce this through some form of login script, well, one thing, it would have to be an environment variable. The second thing is I don't want users changing it. So what I could do is, first of all, let's go through and export it. So if I go through and have -x, but if I add in the R option as well, it's then making it where it cannot be changed. It's a read-only variable or constant. So it's both exported now and it's read-only. When I try now, let's say, and set it to etc host, we can see then that it's a read-only variable. And if I try and go through and do an unset on Ansible config, we can see then that it's a read-only variable. So once that's set within my login script, it's going to remain being set. And even if I log out and log in again, I'm going to get the same value back. So this is great where we want to enforce things that are controlled through variables. Now, I'm hoping you can remember back to the slides, and the slides just didn't stop at constants. We moved on to taking a look at integers. So let's do that now by seeing how we can use integers to control data types. And here we are, ready to dive straight into a little bit of constants. Let's go through and just do our days equals, and then let's say 30. Now, if I go through and take a look at this with declare -p and days, we haven't set any options for this, so it's a plain old variable. So of course it can have a value of 30, but that's seen to be a string value, and of course it's then nothing stopping me going through setting days to equal, let's say, Monday or something like that. So if somebody misunderstands how the variable should be used, we might want to say the number of days before a loan is repaid or something like that. So Monday doesn't make sense. When we go through and take a look at this now, then of course we've been able to accept the value of Monday. So what we could do is, if we went through and then did our declare, and if we go through and put then our -i for integer, so we can only accept numbers, and then go through and specify this to be days equals 30. Now when we go through and take a look at the value here, we can see it's been declared with the option -i. Now it still shows as days equals 30 being as a string, but it won't allow me to go through and put Monday in now. When we go through and put Monday in, even though it seems to work, when I go through and print it out, we can see then that it has a value of 0. So even though this isn't ideal, it would make quite a simple test so long as 0 was not a valid setting, where I could go through and test for something being less than 1 or greater than the upper bound value that we needed to accept. If it was outside of that range, then we could ensure that we didn't accept it. So it's quite a simple thing where we can go through and start using integers. Now, I'm not here to knock variables, but variables only store a single value and they're known as scalar variables. Variables that store multi-values are known as arrays. Now, of course, arrays are all about those instances where you probably want a single variable name, but being able to store more than one value within that variable. And that's where our arrays come in. If we use the declare and lowercase a, we're declaring an indexed array where we use numbered values to represent each of the indexes or separate values that we have stored. We can go through and maybe create ourselves an array called user_name to store different elements of a username within the one variable. We can go through then and start populating it by populating index 0, the first value of the array, with the user's first name, so maybe Bob. And if we then look at the second element, so index 1, we can go through and maybe set this through to the last name. So this is just one simple possibility. So we've got a single variable username, but it's storing two separate values. If I go back and look at the declare command and use the -p to take a look at our username, we can see then that we've got index 0 with Bob and index 1 with a value of Smith. So good old Bob Smith, all of it is stored within the username array. But of course we can access each individual element of this. If I just try and echo out, let's say, the username array, it will actually pick up on the first value that it finds. So it comes back then with index 0 being Bob. It's always going to return then index 0 in this case. But if I want to go through and return different elements of it, I can then go through and make sure that I put the brace brackets around the variable name so it doesn't get confused where we put in the square brackets. And if we use the @ symbol rather than an index value, then it's really all elements of the array. So we see Bob Smith coming back. But again, it's going to be item 0 followed by item 1. If we want to look at individual elements, then of course I can bring out element 0 specifically and element 1, the second element specifically. So we can see then Bob and Smith being able to be printed out separately. Now that's then our indexed array, where we can go through and use these valued numbers to represent each element stored within the array. But if we use the unset command to delete our variable, we can go back up, and if I use the declare command again, but this time an uppercase array, this is an associative array. Sometimes people call these keyed array, where we have key and value pairs. Now I can go back, and now that we've declared it, I can set it up very much in the same way. But instead of using index values, I can have username first, being the first name, and username last, representing the last name. So we can set this, let's say, back to Smith. So with this, then, I can put more useful terms rather than just relying on 0 and 1. So especially useful as the array grows. Again, I can go through and print out the complete list. Here we get Smith and Bob. This is just the order that the values are stored in. We have less control than using an indexed array, where we're always going to have index 0 stored first. But of course, there's nothing stopping me explicitly saying the values that I want. So username first, and then of course username last. So we can pull out each element. The only really difference between associative arrays and indexed arrays is that in an associative array, we can actually specify the name of the key that we want to use. Now, with this done, why don't we go back and make sure we really do understand what we've been talking about as we've gone through and taking a look at this module and have a quick review. Now, you should never take for granted your success. You got here because of the effort that you've put in. And yes, you're at the end of another module, a module where we're going to go through and summarize some of that information. But before we do, sit back, relax, and take that coffee. So we've been taking a look at variables, and variables, we often think, yeah, we understand variables. We use them all of the time. So they are commonly used, but very often they are underused. Now, hopefully that's what we've proved within this module. We looked at the differences between our local variables that are available only to the shell, environment variables that are available both to the shell and available to commands run from the shell, and command variables where we're setting a variable whose scope is only that command as it is executed. We've seen how we can use the declare command to instantiate our variables, but we can also use it to set additional options. Now, there are simple options like the -p, which we can use to print variables, but we've also seen that we can use items like the -u or the -l option to be able to convert to uppercase or lowercase. We can use constants to enforce values, so that's our declare -r for read-only variables. We can use then integers, so declare -i. And with integers, we can also do calculation, so it enforces that the values that we're putting in are not interpreted as strings, but as their numerical versions. And then we finally looked at arrays. Arrays are very useful where more than one value is likely to be stored within that variable. Now, we never sit back and stop learning. So in our next module, we're going to continue learning and starting taking a look at how we can create and work with conditional statements. Hello and welcome to this presentation from Pluralsight. My name is Andrew Mallett, and guess what? I'm going to be your instructor for this module, creating conditional statements. We'll be looking at building conditional statements within our BASH or Z shell, and it doesn't matter which shell that we're using for this module. As we work our way through this, we're going to be taking a look at how we can build simple constructs, and we can use the AND or the OR operator for that. Once we've looked at that, we can then extend into creating if statements where we're able to create far more complex scenarios. With that done, we can look at how we can test for arithmetic evaluations. We'll be looking at how we can compare string values. And we'll move into then looking at how we can use regular expressions as part of our conditional test. Once we've done that, we'll be looking at how we can test file attributes. This is really important because we can build this into our scripts to make sure that a directory doesn't exist before we create it, or the fact that we might have the write permission through to a directory before we try and create a log file in that directory. So there's lots of really cool things that we can do very easily at the command line with these tests. With that done, we move into creating case statements. With these, we can evaluate many different conditions relatively easily and quickly. So we'll be looking at lots of different ways that we can start building in then these conditional expressions. But the first thing is to understand a little bit of what we mean by conditional expressions. They are, in fact, the lifeblood of your script. If the script can't react to different conditions or tests that we instruct it to make across your system, then it really isn't going to be much use. The idea of our script then is it can react to different conditions and perhaps give us feedback or run different elements of the script depending on the conditions that we detect. So the first place of looking at these conditional statements is using very, very simple evaluations directly from our command lines using the AND or the OR operator. So here when we look at it, we've got echo hello, double vertical bar, and echo bye. Now this is our OR operator, and we're saying that one or other of the commands needs to succeed. So if the first command succeeds, there's no need to run the second command. So we only see the echo hello output. We don't see the bye coming on the screen. Well, along with that, we have our AND operator. With the AND operator, we're saying both of these commands must succeed. So we have to run both commands. So we then see hello running and goodbye running. But if hello failed, we wouldn't run the echo bye. Now, these are very, very simple ways of building constructs, and they are, if you like, a simple conditional or if statement. But because we can only run the one command, they are relatively limited. So that's where we can start building up into if statements. Now, the if statements will work in either BASH or ZSH, and they allow then for a conditional test and then one or more action. The if statement starts with the keyword if and finishes with the keyword phi, the reverse of if. So here we're looking at declaring our integer variable for days and setting it to a correct value of 30. But we can then go through and test that input, testing that it is actually correct. So in a simple test, we can go through and use our square brace brackets and then go through and test for our $days variable being LT less than 1. So this is then going to occur when we've either set a value of 0, let's say, or what we're probably testing for is a string value. The string value then will be converted through to 0. We're then going to echo out the correct value. Enter a correct value, you muppet, you've got it wrong. We're only using one action, but we could have multiple actions. So instead of the single action of echo, we could have multiple actions here. We then close our if statement with phi. And of course, we don't get anything being printed out because we've put a correct value, 30 is greater than 1, so we don't meet the condition. If we go through and set it, let's say, for Monday, now Monday then is going to be converted through to an integer. That's going to fail, so it's going to store a value of 0 in days. So now when we go through and test it, we do evaluate to true. Days is less than 0. So we're going to then run the action, and we can see enter correct value being echoed back to our screen. So we're able to provide a little bit of feedback through to our users operating the script. Now, when we were looking at this variable, we were saying that we probably don't want a value less than 1, being 0, but we might also have a maximum value. Maybe we don't want a value greater than 30. Maybe it's a loan period and we shouldn't be lending out resources for more than 30 days. So here where we've set it to 31, we can then go through and use our OR operator between the two tests. So you see we've got our square brackets testing for being less than 1, and we've also then got the square brackets testing $days to be greater than 30. We join these two evaluations together using the two vertical bars, the OR operator that we saw before. We can then say again, we then echo out, enter a correct value, and now that we've got a value of 31, again we're seeing the feedback coming back from our script, enter a correct value. Now this is getting a little bit long-winded, and this is using an older shell. Now using the BASH or ZSH shell, they're more modern shells, and they support a different way of evaluating numerics, and it's a little bit more logical and it can be tidier. So if we go through again setting days to be 31, we can then use the double round brackets or our double parentheses to run our test. Make sure that we have got spaces inside of our parentheses, and then we can use days. We don't even need to put the $. It assumes that we're using a variable, and then we can use the less than symbol 1. We can also build our OR operator directly into the condition. So we got then days being greater than 30. So we've condensed it down and into probably more recognizable operators. If we look at extending our if statement, at the moment we're only testing for one condition, and that's the only action that we're using. If we want to react to multiple conditions, we can try adding in an else statement. So again, we've got our days being equal to 30 here. We've got our test with the advanced arithmetic test that we saw before. we've got there, well, if we hit one of those incorrect values, we're going to echo out, enter a correct value, else echo all good. And you can see with a value of 30, then everything is good, and we echo out all good. If we do need to test for more than one condition, then that's where we can use elif. Think of it as else if, but it's written as elif. So again, we've got then our declare minus I days. Here we're looking at another way that we can populate it. If we're setting this up with a script, we probably would read the input, and we can do that with the read command. So read to the days variable, and we're typing in the value of Monday. The green there that we're seeing on the screen is me typing in the word Monday. We can then go through and start running our tests. And here we've just separated our tests out. So if days is less than 1, we've got enter a numeric value. If days are greater than 30, echoing out that the value is too high. Else echo the value is $days. So we can then go through and echo out it is 25 or it is 30, whatever value we've put in. But obviously putting in a value of Monday, we're getting the response enter a numeric value. Now, it's demo time. So let's start looking at how we can build our simple tests at the command line. Now we've taken a look at testing some conditions, but let's take a look at testing for string values. So let's go through and declare our variable. Here we're using -l, and if you remember, that's for then converting everything to lowercase that's going to be stored within that variable. It doesn't really matter whether you store it in lowercase or uppercase, but then searching for a known case is far more easy. When we go through and populate the variable, here I'm putting in a mixed case of Bob, but we know that it's going to be stored all in lowercase. So then when we look at our test, we can use the single square brackets. So we can go through here, we can see then $username is equal to Bob. Now I'm using the double equal sign here, but we can use a double or single sign. Using the double differentiates from the assignment operator. Also, when we're looking at things like not equal, that would be exclamation mark and equal, or regular expression matches, that would be equal tilde. So as everything then uses two symbols, it's worthwhile keeping it to two equals sign. With that then done, we can then go through and see how we can also test for partial string values. Here we're setting up our lowercase browser variable, we're reading in Firefox, and then we can go through and test. And again, we can test it straight at the command line. We don't really need the if statement. We can just use the and. So here we're looking for then the browser variable ending in Fox. If it does, we can say the browser's Firefox, and that's what we do print. Now, as well as testing for our strings, we can also go through and test for regular expressions. Again, we have to then use the double square brackets. So here we've got a variable. I'm kind of running out of names. We've just called it test_var. We can read into that, and we're reading in the American spelling of color. But we can then go through when we test for it using the match operator equals and tilde. We can then have it then optionally including the letter U. So we can look for it with American or UK spelling. We've got then our question mark, which follows the U, and that makes the U optional within our regular expression. We can also then go through and say what we have matched on. We've got a variable that's being set up, our bash_rematch. It's actually an array, so we're looking for our first match. We've only got one match, so that's going to be 0. So why don't we move out to the command line, start testing for these string values, both partial strings, full strings, as well as going through looking out for our regular expressions. Now, come on, you good people. Let's go through and find our command line and go through and make sure that we can adequately test our string values, regular expressions, and partial strings. No, when I said strings, I didn't mean that type of strings. Oh, never mind. So we're going to begin the demonstration with testing for our simple string values. If we want to test simple strings, then we can do that with our double equals sign. So let's go through and set up a variable. As we saw in the slides, when I'm setting up the variable, I'm probably going to set it to a known case. So if I use, let's say, -l for lowercase, and we can have it then, let's say, as user_name. So that's then set up my variable to store all of the characters in lowercase. It's going to make it a lot easier when I then go through and search for information. As I go through then, I can read into the username variable. I'm just using escape and dot to pull up the variable name, the previous argument, and we can see now that we're reading into it. So let's go through then and put Bob in mixed case. But that's now going to be stored all in lowercase. It's going to make my testing much easier. And these are easy things that we can start building into our script to make sure that then testing becomes much easier later on within the script. But we can test directly from the command line. And at this stage, I don't even need to move into my if statement. We know that we can then go through and just test with our square bracket. Look for our variable, so $user_name. Again, I can use tab completion. Just typing part of it and then the tab key, we know we're looking for variables because I started with the dollar symbol. And then we can say is equal, so the double equal sign. We can get away with a single equal sign, but we might as well keep to the double equals because I can use the not equal and also the regular expression match, which uses 2 characters. So we get used to it. And then we can put our string then Bob. I'm testing obviously for lowercase here because that's how it's stored, and close off my test. Now, I don't even need to go through and print any results. I can see if it is Bob by going through and echoing out the special variable, so dollar and question mark. So that does match because we've got a value of 0. If you want to check that it's not Bob, then as I say, then that's my equality operator. That's my negative equality, so not equal to Bob. So the username does not equal Bob. When we go through and look at our variable, we can see now that we've got a value of 1. So that evaluated to false. Come on, you horrible people. Let's go through and test some partial strings. Now let's go through and set up our variable again for our username. So we can go through, same thing as before, declare minus lowercase, and then user_name. That just ensures that everything is set up the way that we want. Now then, just suppose that we might have admin accounts and ordinary accounts. So we might have Bob_admin and Jill_admin, Sammy_admin. So we might want to be checking for the existence of a partial string _admin. So let's look at how we can do this. If we go through then and read into our variable, we can go through and then put Bob_admin. So we're then suggesting that each of our admin accounts will have admin at the end, and Bob might have 2 accounts, Bob_admin and Bob_user, something like that. We want to see if you're the admin account, but whether it's Bob_admin or Jill_admin, it doesn't really matter. So we can go through into our test, but we're going to use then the advanced test. So this is available in shells such as BASH and ZSH. So our double square brackets, leave a space, and then we can go through and put in then our $_username, and then is equal to. Now I'm not going to quote this now because we want to go through and make sure that we can still expand then our star. So we can go through and put star and then _admin. So we don't care what it starts with, but it's going to end in _admin. We can also put the wildcard at the end as well if we wanted to, but we know the account name should end in admin. Just go through, close this off, and then hit our enter key. So again, we don't need to do any other tests. We know that this is going to be a success or a failure, and we can go through, use our echo and read our special variable, and we can see then that that was true. If we go through and perhaps test for it being an ordinary user account, so ending in _user, now we can see then that's returning false, so that does not evaluate to true. So this becomes a good way that we can then go through and test for substrings or partial elements within a variable or file that we're reading in. The final element of this mini section is to match regular expressions. Now, another way of testing for partial strings or substrings is to use the regular expression. This is a much richer way of searching for text and then can be used to search for things we probably couldn't even imagine. Now, the regular expression is very rich to the language, so we won't be looking too much at the regular expression language. There are other courses on Pluralsight that will help you with that. We will want to look at really how we can use the match operator. So let's go through then and let's say unset our username. Let's go through and set up all again. So we've cleared that. We know that we've got nothing in. We can go through then and declare -l our username. So we can set this up again. We can go through, we've got no value in it at the moment, but we can go through then and read in the username. Remember, we're using the read because we're likely to be using this to gain user input during the script. So we can go through then and read into our username, and we can then go through and put, let's say, our Bob_admin. So we know then the username that we're making use of. Don't forget that we can go through and use our declare and -p to be able to print this out. And again, I can use user_n and then just hit my tab key and it's going to complete. So we can see then that we've got our Bob_admin, so it's there. Now, using that same type of mechanism for our test, so using our advanced test and then bringing up our variable, so $user_name. With that done, we're going to use the operator now, equals and then tilde. So this is looking for a match. And we're going to specify then _admin and then $. $. Really is the anchor for the end of the string. So we're looking for it ending in $. We can close off then our double square brackets, making sure that we leave a space. Now as we go through and take a look at our echo and our special variable, we can then go through and see whether that succeeded. It ended in admin. And obviously if we look at it for ending in user, then we're not going to match. So we can see then that we failed on that. But as well as this, we actually create another variable. If I go through and look at declare -p, and then if we use our bash and then _rematch, we can see then that we've got a variable bash_rematch. That's going to show what we've matched on. Now obviously we didn't match on anything last time, but if we go back and make sure that we do match on something, so if we go back and use our _admin and then go through and look at our bash rematch, we can see then that index 0 has a value of _admin. So we could use this to print what we had actually matched upon. Now, as I say, the regular expression language is an amazingly rich language, and I recommend that you become familiar with it. But you can see how powerful it can become in searching for text within your variables or files that you need to search. Really is a great tool, and you should learn it. Now, so far, we've really concentrated on using our brackets for our test command. But when we go through and take a look at both the test command, the single square brackets, and the double square brackets, we're able to see that test is actually a shell built in. The single bracket is also a shell built in. It's actually a synonym for the command test. When we look at the double square brackets, well, that's a shell keyword, but again, it still really is working with shell built-ins. So these all really are very equivalent to the original command test. So we can start looking at how we can use test. Remember, whenever we talk about the command test, we can use the single square brackets as an alternative. So one of the things that we can do, as well as testing for the conditions we've been looking at so far, is reading in file attributes. So for example here, we can test to see that -f, so we can go through and see that the etc host is a regular file. Equally as using the test command, we could use the advanced test command with our double square brackets and run the same type of test. Now, -f is to test for a regular file. When we look at -d, that's testing for a directory. Moving on, we can see that using the uppercase L, we can test for symbolic links. Using -e is test just for the existence of a file, where we're not so worried about its type. -r is looking for the read permission, but we can equally use -w for the write permission and -x for our execute permission. When we're looking at -k, we can test for the sticky bit. Now, of course, that's then set on the temp directory, and if you remember, the sticky bit is preventing you from deleting files unless you're the owner of that file. When we look at -s, that's for the set user ID bit. It's set on programs like /bin/passwd, so that when we execute it, we're running with the permissions of the owner of the file. Often this is root. Now, demo time, isn't it? Let's go through and work with the test command and see how we can perform some of these file tests. Now, I do think we've run through this in previous modules, but don't underestimate the importance of running through these demonstrations yourselves to get great hands-on experience and real learning. Now let's begin with that command type. You might not have come across it before, but it's a good way to detect what type of command something is. So if I do a type on test, we can see then that that's a shell built in. It's built into the bash shell, it's built in also to our Z shell. But I can accept multiple arguments. So we can also then put the synonym for test, which is our single square brackets. And we can see then that's also a shell built in. But we also, within our advanced shells, such as ZSH and BASH, have the double square brackets, which is a shell keyword, and that's interpreted still by using the test, but advanced elements of it. So we can use either our test commands or one of the brackets. So if we want to go through then, and let's say test -f to see if /etc is a regular file. So we can see we can run that test. If we go through and look at our results, we should realize that this is a directory, and of course then when we look at the result of this, then the result is false. Whereas if we go through and check to see if it's a directory, we can see then as we go through and check, then it's coming back as true. Now, even though these tests are quite facile, quite simple, they can be really useful to us when we start putting them to use within our scripts. At the moment, we're not going to build a script, but we can see how it could be useful by combining some of these tests together with actions. So if we go through and do a test, and if we go through and test to see if exists, so -e, and go through and then check for dir1. So we're going to check to see if there's any file called dir1, no matter if it's a directory or a file. We can then go through and say, well, look, if that doesn't exist, so we can go through then and use the OR operator. So if the first command fails, we'll go through then and mukdir dir1. So now we will have created the directory because hopefully we didn't have a file called dir1 before. As we go through now and list it, we can see then that it's been created today. We've just created this new directory 1. So we can go through and check the existence of a file or a directory before we go ahead and try and create it. So this can be really useful. But maybe we also want to write to a directory, but we want to check before we do so that the user has permissions. So if I use test -w, it's testing that I have the right permission. So we're testing it on dir1. Now, of course, I do have permissions, but we're looking at the logic behind this. If that is successful, so I do have permissions, then let's go through then and create a new file. If we didn't have rights, we can say, look, you don't have rights to that directory, so perhaps we need to write elsewhere. Now, as we've touched that file, we can now, of course, go through and list the directory, and we can see then that the file has been created. So with a little bit of thought and careful planning, we can start making very robust scripts by using the correct file tests. Now, so far, we really haven't created any scripts. The reality is there is no need to create a script because everything that we do within a script we can replicate at the command line. But we can use a script as a slight demonstration to be able to go through and show you how you can start putting some of these techniques together. Now we can see the script displayed for you here, and of course you can pause to be able to write this out or copy it out. You also should be able to download an example through the course downloads. But for the moment, let's go through and take a look at creating a script where we can put some of these elements together to see how we can use them. Now you do have to ask yourself, what type of scripting course is this? We've not created any scripts. Now obviously, as we've seen, there's been no real need to create scripts because the keywords we can use from the command line. But let's go through now and put everything together within a little script. So use your text editor of choice. I'm using Vim. We're going to create then a file dir.sh. Doesn't really matter what it's called. Now, of course, we're going to then start off with our shebang, and I'm going to be using the bash shell, but again, we could use the bash shell, or we could use the ZSH shell. Only really when we get into our final module of this course, when we're looking at loops, do we have more looping structures that are available to us in the Z shell, when we concentrate a lot then on the Z shell. But for the moment, we can use either shell, and bash seems a very good choice for me. Now, with that in place, we can then go through and declare our variable. And if we go through then and declare using -l, so we force lowercase of the value, and then we're creating a variable that we're going to call dir. Now, the variable can be in uppercase, but the contents will be stored in lowercase. As we go through then, we can start echoing out a prompt for a user. Echo -n is then going to ensure that we don't do a carriage return at the end of the echo statement. So our prompt is on the same line as where the user is going to type information. Now, as then they start typing, they're going to put in a directory name. That directory name is going to be converted to lowercase, and then we can read that into our dir variable. Now, we can go through and take a look then at what already exists. So we can run our tests. So we can use then the file test -e to see if it exists, because we don't care really what type of file it is. We're not going to be able to create it if it already exists. So we're testing then to see if $dir already exists. Don't forget to put the spaces inside of your double square brackets. Can't be pushed up against any of the elements. Now, it's easier to read when we write it into a script like this. We don't have to, as we've done on the command line, have everything on the one line. So we can then tab that in a little bit, and then tab the action list in. Here we're going to say then that the directory already exists, so $dir already exists. We can then exit, and we can exit with an error code of 1. We'll actually have 2 exit conditions as we see within this script, and we can then determine by the error number, the exit number, what error occurred. Now we're going to go into our else statement, and as part of our else statement, we're then going to say, okay, if the directory doesn't exist, we can go ahead and create it, but we want to check that we've got permissions. So as we continue with our conditional statement, we can then go through and look for -w, that it's writable, and then pwd, the directory that we're working in. Now, with that done, we can then go through as before into our then block, our action list. With this, then, we can go through and create the directory. We're saying if the directory that we're working in is writable, we can go ahead and create the directory. Else, we can go through and display a message. So echo out something like we don't have permissions. So we don't have permissions through to $pwd or whatever we want to put in our message. But it's giving good feedback to our users. So although it's a very trivial script, we can see how we can use these tests to make it more reliable. Now here we're using then an exit code of 2, and we can use then our $? variable to interrogate the exit code so we can get some understanding of what happened. Now that looks all okay. Be careful with ending the if statement, because obviously we've got to end both if statements. But with the file saved, then we can go through and make the script executable. So of course we're going to use our good friend chmod, so chmod plus x, and then our dir.sh. So now we can go through and execute this as we go through and try. So ./dir.sh. Man, look at this prompt. It's marvellous, isn't it? Let's go through and create a directory called mydir. Now that has worked. Look at that. No error messages. But if we go through and run it again, put in exactly the same directory name, mydir already exists. So we can check that our first logic check is really working the way that we want it, and how wonderful this starts to look. Okay, we've tested one logic step, but now let's go through and check the second logic check. Moving into the etc directory, we can still execute our script. Rather than going ./, we can put then home and tux and dir.sh. Again, we get this wonderfully crafted prompt. We can create a directory called dir1 with absolutely no thought. And look at this, we've got a new message. We don't have permission through to the etc directory. And we could even go through and check the $? Variable to see this will have an exit code of 2. Now, we really aren't finished yet. We've got more. Yes, there is more. Another conditional statement is the case statement. This could be really useful when we need to test for multiple conditions and we don't want to use our elif statements. So we begin with case. Here we're investigating the $user and we store the value of $user in memory. We can check then that if it's tux. So we use tux and then our parentheses ends what we're searching for. If it is tux, we're going to echo out, "Ooh, you are cool." Note how we end and the use of the double semicolon. Now, we're not tux, we must be somebody else. So if we're root, we can echo out, "Okay, you're the boss." And again, that double semicolon to end that code block. Again, we could have multiple actions before we have the semicolons. To end the case statement, we reverse it, so we have esac, much in the same way as we reverse if to become fee. Now, if we want to go through and take a practical look at how we might use this, let's take a look at plural sites for seasons. When we go through and take a look, we're using date plus %b. Now, that's going to return the short form of the month. Now, obviously, we're looking at that as far as we're concerned with the anglicized spelling. If you're working in a different geographic area, then of course you can test the script with different values. But in the anglicized version, if it's December, January or February, we can echo out that it's winter. For ease, we're putting the 2 semicolons on the same line, and that does work. Now, of course, if it's March, April or May, we can echo out that it's spring. If it's June, July or August, you've guessed it, it's going to be summer, which only leaves winter. It's going to be September, October and November. And again, then closing with our esac statement. Now, with this script then done and dusted, let's go through and practice using it and writing it from our command line. So come on, let's get our typing pencils out and make sure that we can create and understand this case statement. The first thing is to make sure that we understand the output of the date command. So if I look at date plus %b, we can see that we get the short form of the month. It's also displayed in mixed case. Now I can test for it by writing in mixed case, but it always seems much easier to test in lowercase or all uppercase rather than having to worry about the case of the string. So that's why when we create the variable, we'll store it as lowercase. Now if we go through and create then ourselves a script, season.sh, and again go through and put the shell interpreter that we want to use. So we're going to be using, let's say, the bash shell, but remember use bash or ZSH, either is going to work quite well. As we go through then we can put in that declare command. We've used this several times now, so -l month. But we can also go through and instantiate, set the value of the variable as well as declaring it. So it's going to be the output, so $parentheses, the output of the command date plus %b. So we don't put input ourselves, we get input from the date command. So the whole script is automated for us. We open up our case statement, so the word case, and we read in then the value of $month. And we only need to read it once. We check for our list by using the in keyword, and then we start really creating our list. So this is going to be December or Dec or Jan or and then Feb. So we put the 3 values that we want for winter and we close off our parentheses. We could also, for our conditional test, have an opening parentheses on the left, so before December, but it's not required and is often omitted. As we then continue, we can put our action list, and we're going to have just one item to echo that it's winter. So we can then go through and put that. And just as we did in the slides, to save space, I can have my double semicolons on the same line. But that could equally be on a second line, indicating then we've finished our action list. As we continue, then we can put in March, April, and May. So that's our second list that we're going to check for. And of course, then we know where we're going with this. We're going to echo out that it is spring. So echo and spring. And don't forget then to end the block with our double semicolons. Now, of course, then we can go through and put in our summer and our autumn and end the case statement with ESAC. But there you go, that's it done. Now you can see, as I'm trying to save here, that I can't write through to this directory. I've probably opened it up in etc. But if I just go back and then escape and W and write through to a different file, so tilde and season.sh, I can easily then save this to a different file. So that's now saved as the season.sh. I can then go through and quit an exclamation mark to make sure then that I can quit without trying to save back to the etc directory. Moving back into my home directory, we know we're going to set the permissions now, so let's go through and do it. Chmod u+x, if we want to be a little bit more secure, season.sh. As we run it, there we go, it must be spring. So we can see how we can start using case statements to work for us and eliminating the need for multiple elif statements. Now, having looked at this, why don't we go back to the slides and summarize what we've looked at? We've seen quite a lot in this module, so we should take time to make sure that it's all sunk in. Now, give yourself a great big pat on the back, take a cup of coffee and a chocolate cookie. You've done really well. This is a long module and I'm hoping you've learned tons from it. As we started with, we were looking at the simple and or constructs. So the double ampersand representing and, the double vertical bar representing or. So if we only need a single action to happen, we can build these simple constructs. Where we need something a little bit more complex, we can start building if statements. So we've got if our condition, then our action list, followed by the end of the if statement with fi. And we can build in elif statements and else statements as well within the if statement. When we're looking at our conditional tests, we saw then that we've got within our advanced shells, such as BASH and ZSH, we're able to do our arithmetic calculations if we use the double parentheses. Now this makes it a little bit easier because I can then assume that this is a variable. I don't need to go $days, and instead of using the -LT syntax, I can go through and use the far more acceptable less than 1 as we're seeing here. As we go through, we can start building into this again with our advanced test. We're able then to go through and building our and ors into the conditional test rather than having to have multiple conditions. So here for our test, we didn't want the value to be less than 0 or greater than 30. So we can build a single conditional test that includes the or statement as part of it. And we can do this in our advanced test, but we can't do it in a simple test. Now, as well with our advanced shell, we're able to use the double square brackets to test for strings. Now, we're going to use this because it keeps then consistency. As well as testing then for complete strings, I can test for partial strings, so J star. And of course, I can go through and use things like not equal to January. As well as that, we can go through and look for regular expressions. So we've got then our match operator that we can use within our double square brackets. And we can look at it for matching then ending in a Y. So of course this is going to match things like January, but it's not going to match something like December. We also have string tests that we can do. Again, we could do this within our single square brackets or our double square brackets. But here, where we're looking for -s, we're making sure then that the /bin/password program has the set user ID bit configured. Finally, we looked at case statements. And the basic construct, as we can see here, is then we can read the case of something like a variable and then check for it being in, and then our test condition, so our values like January, December, or whatever, and then our actions. At the end of our action list, so the final action, we have a double semicolon, and then we end a case statement with ESAC. So I say a lot in here, but also really, really good stuff, the bread and butter of your scripts. Now we're going to move on from here. In our next module, we're looking at building effective functions as opposed to building ineffective functions, I suppose. But let's look how we can build really good functions in our next module. Hello and welcome to this Pluralsight presentation. My name is Andrew Mallet and I'm delighted to be here as your instructor, and I'm going to help guide you through the module Building Effective Functions. Now as we go through, of course, we're looking at functions. So we're going to see how we can list functions from our command line shell. We'll see, of course, how we can go through and write or create our functions. Once we've created them, then we need to execute these functions. So that's called calling functions. We'll be looking at exporting functions. So much in the same way as variables, the function is going to be local to the shell that it's defined in. If we need it available to subshells, we can export the function. Now functions are like mini blocks of code, and they too can accept arguments. So we see how we can pass arguments and work with arguments within our functions, as well as working with return values, stuff that can be returned by the function. To finish up though, we're going to look at an important topic, making sure that we always design our functions with best practice in mind. Now to begin with, let's make sure we're clear on what a function is as far as the command line shell is concerned. Now our shell functions themselves just encapsulate blocks of code. These code blocks are stored into named elements and then can be executed, or we said the term is called, from scripts or directly at the command line itself. Now if we take a look at an extremely simple function, we can go ahead and declare the function with the function command. Here we're calling the function say hello. The parentheses just really show that it can accept arguments. And then we open up our brace bracket. That brace bracket can be on the same line as function or on the following line. Then we can go through and put our lump of code. Here we've just got one line, but it could be multiple lines of code that we add in. And then we close our brace bracket. And that's the end of the function. To call the function, then it simply is just say _ hello. Now we can also pass arguments through it, but if we're not dealing with those arguments in the script, then it's going to silently ignore those arguments. Once we've created functions, we can go through and list them, but to be honest, we're going to have a heap of functions within our shell in any case. If we use the lowercase f, we're going to list all of the functions and the details of their content. If we just want a summary, the function name, then we can use the uppercase F. To show what I mean by the detail of a function, if we use a declare -f on the function we just created, say _ hello, we then see the definition of our function being printed back. Now, talk is cheap, and we know that learning from the command line and a demonstration is going to be much better. And again, I do emphasize the need for you to practice this on your own system. We're going to be taking a look at how we can create and write a function, how we can execute or call the function, as well as listing our functions. Are you ready? Let's go. Now, I really don't think I need to introduce you this system. You know this is my Ubuntu 18.04 system, and I happen to be working at the BASH shell. The reality is, if you want to be working at the Z shell or the bash shell, either are going to work for you. We're going to be taking a look at how we work with functions, and they're going to behave in a similar way across both of those shells. So the first thing we can go through and use is the function command to create ourselves a brand new function. We called it say hello in the slide, so let's stick with that. Now I happen to be using lowercase here and an underscore, but so long as the name is not in use, you can call it whatever you want, so feel free. We can go through and put our parentheses, our round brackets. These then go through and indicate they can accept arguments. We'll be looking at arguments later. And then we can open up our code block with the brace bracket. So of course this is the left brace bracket being the opener, and this may be on the end of the first line where we've declared our function, or it can be at the start of the following line. Out of habit, I tend to put it on the first line. Now we're into our continuation prompt, and we can start adding in code. Now we're not going to add in too much. We can just go echo hello or whatever you want. But of course, when we're building a function for real, we're likely to have multiple lines of code. Having a single line of code is really the same as calling or executing the function, so it wouldn't really give us any benefits. But with that done, we can go through then and close our function, so the right brace bracket. And there you go, it's created. Now to execute it or call it, I can go say, if I just go say underscore, it will pick it up with tab completion. So you can see then that we've got say hello, and then, of course, we've got the hello message coming back. So brilliant, the function is working. Now, just like a script, there's nothing stopping us to pass parameters or arguments through to it, but they're silently ignored if we're not dealing with those arguments inside of the function. We can list these functions with the declare. Declare -f is going to give me the details of my function, which to be honest is probably a little bit too much when we list them all as we're doing here. So if I clear the screen, we only want to see the name of the function and use the uppercase F. So we can still see there are a lot of functions that are created, but at least we can start seeing more of the names and less of the detail. Where we do want detail, let's go back to our lowercase f and then put in the function name so we can print out then the definition of that function. Really useful, because if we have previously created a function or somebody's created a function for us, we can go through and see exactly what it's doing. And the functions just exist in memory, so they execute from the memory of our shell. But there you go, we can create and execute and list functions. Now, exporting functions is not that big a deal. It's very much like variables at the command line. If the functions aren't exported, then they're available to that shell, but not to any subshell. So that's going to be a problem for us if we fire scripts that are dependent on functions in our main shell. But to overcome that, we export it. And that's exactly what we're going to be taking a look at now. We'll take a look at how we export our functions from the shell. Ah, my precious, we meet again. So yes, we're on the command line, and we can already see that we've got our function set up, say hello. But if I start another bash shell, and this might be the same as if we're running a script, we're going to initiate a new bash shell. But in that bash shell, if I try now to say hello, I'm tabbing here, but it's not working. But if I go through and try saying hello, the command is not found. So let's go through and exit. That's going to return back to my main or master shell. And if I go through and let's up arrow key, and we can say then that we can declare -x just as if we were exporting a variable, and then have the -f to say that it's a function that we're exporting. Now when I go through into my bash shell, if we try and access the say hello, we can see we have direct access to it now. So this could be really important whether we're running subshells or just creating functions within a master shell that we want accessible to our scripts. We're going to need to export those functions. Now, you're probably not going to be surprised to realize that you can pass arguments through to functions, and it's done in a very similar way to that which you would do with a shell script. So here we can go through, let's say if we've got a function called create_user, we can pass then the value of tux as an argument. Inside the function, that value of tux would be seen as $1, the first argument. Obviously, we add more. It could be $1, $2, $3, or to access all of them, we could use $*. As well as passing arguments into our function, we can have return values, and the return values act in a similar way to exit. Exit would leave a script, well, return leaves the function. And we also have a return code, much in the same way we would have an exit code. So if we had return and any non-zero value, then that's generally what we're going to be doing on an error, and is going to report a failure of the function. If we return 0, a 0 value is generally going to be on success, and then is saying that the function ran successfully. Now, if we want to start looking at all of this put together in something a little bit more useful than just displaying hello, we can go through and create this function, create_user. So we can see it's set up in very much the same way. One of the first things we do, though, is a test. On that test, we're looking at the success or failure of the getEnt command. So we're going to go through and say that if it succeeds, so if getEnt password $1, our first argument, if that actually then does exist, then the user is already on our system and we can't create that user. So we return then, we leave the function and we have a return value of 1. So that's saying it's some form of failure. Else, so if the getEnt command failed, i.e. the user wasn't there, then we can go through and echo out that we're creating the user. We can go through then and use sudo and user add our user account, and then we can return 0. Returning 0 is saying then that we've succeeded. Again, we're going to leave the function at this point. We can then go through and close our if statement and then close off our brace brackets. So now we see we've got a little bit more within our function, a lot more than just echoing out hello, and we can start seeing how we can put our functions to good use. But why don't we go through and practice some of this from the command line? Okay, good people, we're going to dive in and make sure that we understand the complexities that we can put into our functions. So let's go through and create ourselves a brand new function. So using the function command, we'll call it create user, same thing as we had in our slides. So we know how to start this off now. Now, the first thing that we're going to do here is start doing some tests. And of course, this is what we might reasonably do in the real world. So we can go through and put our if statement and then take a look for our condition. We can run straightforward commands and just look at the success or failure of that command. So we're going to run the command getEnt. GetEnt then can interrogate different databases. And we're going to be looking in the password database. And we're going to look then for the user that we specify with our first argument, so $1. Now, logically, we might also go through and check that we have supplied arguments. We're not doing that here, but we get the idea it would be reasonable to check that we have actually provided an argument. Now, if the user is there, it's going to print it to the screen, so we probably don't want to see that. So let's go through then and redirect our standard output to /dev/null, just so the user won't see the output. So that's the command. So we're going to be checking for success or failure of that command. If the user does exist, then the getEnt command is going to report success. So we want to then go through and probably echo something like the user already exists. So if we go through and say the user, and then let's say $1 already exists, or whatever message you want to display. With that done, we can then go through and instead of just continuing, we can leave the script or the function at this point. So we use then our return keyword, and if we put a non-zero value, so here I'm putting 1, then if we were testing for success or failure of the function, we're going to see then that this function has failed. Now we can get into the else block. We only need to test for our conditions. Either the user does exist or the user doesn't exist. So if the user doesn't exist, obviously we can then go through and create the user. So we might do something like echo creating our new user, and let's say $1. With all of that done, we can then go through and do sudo and user add and specify $1. With that done, we can go through and return. And if we choose 0, then that's a success. So obviously we've created the user. We can have the function return success. We now finished our if block, so we can use phi. And now we're finished on our function. So with that done, let's go through and see if it works. If we go through then and create user, and if I try, let's say, use tux, well, the tux already exists. And if I go through and read the return parameter, so reading, remember the variable, dollar, have you remembered it yet? Dollar, question mark, there you go. You hadn't forgotten, had you? So we've got then an error coming from that function of 1. If we then go through and say create user and then Bobby, we can see then that we've created that user, Bobby. We can kind of prove that. If I try to create the user again, now that user already exists. So we can start seeing that rather than just a very simple function, that all it does is print to the screen. That was a great demonstration of how to create functions, but now we can see the real strength of a function because we can encapsulate all of that code within the simple terms create user. Okay, so what about best practices? Well, to be honest, this is something we should always consider, especially when we're starting to learn about making functions. If we consider best practice from our outset, then we're going to be building them correctly as a matter of course. Now, a lot of best practice as far as function building is concerned is to ensuring that functions are stand-alone, that the function can be copied from one script to another script and to be run irrelevant of the surrounding environment. Let me show you what I mean. If we start looking at some good versus bad or bad versus good, this would not be so good. Here we're echoing out a variable called $age, and obviously if that variable doesn't exist, then we're going to be printing nothing. So it really isn't that useful. Whereas we unset our variable, and we can also go through and clear the function, so unset -f print _age, we can go and then create it again. So as we create it again, we're then setting our variable $age to equal $1. Now, of course, we could just reference it as $1, but from a documentation point of view, it's much easier to understand what that variable is being used for if we name the variable inside of the function. So always a good idea. Another thing that we do here, we have the local keyword in front of $age. This is then just to ensure that the age variable is available only to the function and doesn't then escape or leak out into the shell afterwards. So we're not going to be rewriting any age variable that might already be in use within the shell. We can then echo out our $age, and that's going to be the parameter that we've passed through into our function. So the second example is a lot more useful in the fact that it's not reliant or affecting anything outside of the function itself. Now, as always, it's a good idea to put some of this into practice, and we can see what we mean about that variable leaking out. So we're going to move out to our command line so we can investigate some of these good and bad habits. Now, I really do believe that we're going to be able to see some pretty cool stuff by working at the command line. So let's go through then and create our function print age. Now, we're not going to be starting with the absolute trivial one where we're just printing out the value of a variable. So we'll start it so we can really investigate the use of the local keyword. So as we go through and then create our function, we can begin then by setting our age variable, and we just set it in the normal way. So age equals $1. Now forget about local for the moment, but this is really good idea to name our variables. Obviously, just accepting the arguments, they have to be called $1, $2, $3. And especially if we are using multiple arguments, it's easy to lose track of which argument is meant to represent which value. So naming your input arguments early on by variables such as age really does make sense. We can then go through and print that, so echo $age. With that all done, then we can go through and close our function. So this looks pretty good, and a lot of us might have designed functions like this, but there is an underlying problem. If we check at the moment, we currently don't have an age variable set within our shell. But when we run our function, we will have, and that's not a desired effect. So if we go through and print age, and we'll say our age is 99, now go back and look at that $age variable, it's then carried across from our function into our shell. Now this could be a really bad thing if we had an existing age variable and that had been overwritten. We definitely don't want that, and we want to design our functions to be completely standalone. So that's where the local keyword comes in. And we can go in and redesign our function to be a little bit more compliant with our best practices we saw within the slides. So let's go through and just redefine it. So if we go back up to our print age, it's not going to take long to go through and do. But now we just have our local keyword, local age. So now we're making the age variable only available to this function. Completely standalone. So it's still being equal to our input parameter or argument. We can echo it out exactly as before, $age, but we're not affecting the calling shell. So of course we still have our age variable set within the shell. So if we read it before we run the function, it's set to 99, and we don't want the function to touch that. As we then go through and print our age, maybe we're only 44 now, so we've shrunk a few years. Now as we go through and echo out that variable, we haven't touched the underlying shell, and this is the desired effect and the way we should consider building our functions. Go on, take that coffee, sip it back, you've deserved it. We've reached the end of another module, a module where we've really been able to see how we can start building clever code, lumps of code that we can block together in these elements called functions. Let's review what we've seen. No, really, you do have to understand what a great effort that you've made to come this far and what you've gone and learned. Let's just review some of the stuff that you've put into your vocabulary as far as functions are concerned. Well, you've been able to list functions, both using the -f option with declare, so you can see the details of the functions. Using the -F, we then get a summary, really just a list of the function names. Along with that, we've seen how we can export functions to make them available to subshells, and that would include scripts. So we can use then the declare -x just as we would with a variable that we wanted to export. Don't forget, we also use the -f option to say that it's a function that we're working with. If we want to clear our functions, we can unset them. So we use the unset command the same way as we do with a variable, but again with the option -f and our function name. When we're looking to leave a function, we can use the return keyword. The return keyword is used then with a numerical value. If it's anything other than a 0 value, it's indicating a failure of some instance. If we return a 0 value, we're saying the function worked correctly. Also, we saw that when we're looking at variables, we can use variables with the local keyword. It's important if we want to ensure that we're not going to affect variables outside of the function to keep them local. And that goes to the big picture of making sure that we design our function to be standalone, so it's not going to affect anything outside of the function. Equally, it's not going to be affected by anything outside of the function. So making sure that we use input parameters or arguments rather than reliant on picking up from variables that we've declared outside of the function. And that's it. You're now an expert on function. And as I say, you've done a huge amount to get this far. But we're not finished yet. We're going to be moving ahead now to see how we can start understanding our shell iterations by using loops. And I hope you're going to enjoy me in that module very soon. Hello and welcome back. My name is Andrew Mallett and I'm delighted to be here as your instructor to help guide you through the Pluralsight module, Understanding Shell Iteration Using Loops. So let's get a little bit loopy and understand all of the things that we can do with this. Now, as we work our way through the module, we'll be taking a look at different types of loop, including those in the while and until family. We'll be taking a look at for loops. We'll look at how we can control loops by adding in the break and continue statements. We'll be taking a look at how we can use the for each loop. So this is something that's available in the ZSH, but not available to us in BASH. With that done and dusted, we're going to take a look at really putting this complete course together, everything thrown into a menu. So we can go through and start looking at creating while loops to iterate through the menu, having case statements to go through and interrogate what we've selected, and from those case statements we can go through and select functions to encapsulate our code. So we'll be able to take a look at many of the things that we've looked at through the complete course and see practical application. First off is understanding exactly what we mean by loops. So looping structures allow us to quickly iterate through a list or group of items very efficiently. We only really need to write the code that we need once, and then we can process each item in the list. So it'd be very easy for us if we needed to create, let's say, 12 users, all needing very similar properties, to be able to go through and create those 12 users. The first looping structures that we're going to investigate are the while and until loops. They're very, very similar. They're really just the reverse of each other. While loops will go through and loop whilst a condition is true. Until loops will loop until the condition becomes true. So taking a look at the while loop, it would be very easy for us to use the declare command and set up an integer variable that we're just calling x, simple number. As we then go through in our looping structure, whilst x is still greater than 0, we can go through our looping structure. The looping structure will start with the keyword do and end with the keyword done. Then within our looping structure, we echo out the value of x. Now it's very important to make sure then that we either increment or decrement depending in which way we're moving. Here obviously we're reducing our figure to get to 0, so we're doing an x minus 0. If we don't reassign the value of x, we're going to be looping forever because we haven't provided a mechanism for x ever to change. Similarly, with the until loop, we can go through, set up our variable. Make sure that we do set the variable up again. If we don't, the variable will be left as its previous value of 0. So we can then go through into our until loop, and now we're saying until x is equal to 0. So it's the same process that we're going through, but we're just expressing it in a slightly different manner. And often it is just a matter of choice as to whether you use the until or while loop. But again, the process is going to be the same. We've got our do and done keywords, and our block is exactly the same, echoing out the value of the variable and then decreasing the value of x for each iteration. So we're going to be printing out then our value from 10 through to 1. Come on, let's go through and take a look at some of these loops. Now, come on then, let's go through and find our Ubuntu command line and check that we can go through and create our while and until looping structures. Oh, and look at this, we're enjoying some fresh pixels at the command line. Now, we don't have to do exactly what we saw within the slides, but let's start in our same way by declaring our variable. So we can set it up then to accept integers, and this is always good practice to go back on what we've previously looked at to make sure it really has sunk in. So declare -i is creating a variable that can store integers. We can set it up for the variable x to have a value of 0. When we go through and if we want to print out its value, so -p, and remember the variable name was just x, we can there see that it is an integer variable with a value currently of 0. So we're up and running with what we want with our variable x, and we can use this within our loop. We're going to use a while loop to begin with, and we can go through then into our advanced arithmetic test, so our double parentheses, followed by a space. Again, those spaces are really important. With that done, we can then go through and take a look at what we want to test for. So we can go through and say whilst x, and we can then go through and specify perhaps is less than 11. So we can show then x at its current value 0 and counting all the way up to 10. Once we get to 10, the next loop round, it will be assign a value of 11, and in that case, we're no longer going to be evaluating to true, because we're saying the variable x has to be less than 11. So that's our end of line, so a semicolon, start our do block, and then we can go through and echo out the current iteration of the variable x. So of course it's going to start on 0, but we don't want to be counting backwards as we did within the slides. So here we're going to go through and reassign our variable x. So x equals x plus 1. So it doesn't really matter whether we're counting up or counting down, incrementing or decrementing, so long as we're going in the right direction for our test. So that's the only code that we need, but don't forget to put that in. Without that, of course, then we're not changing the value of x. We can put in our done keyword, hit enter, and we can see then that we go from 0, our current value, all the way through to 10. If we go through now and take a look at the value of x, we can see then that we did hit that upper value of 11, but once we got to 11, we didn't loop round anymore. So this was the way that we wanted it. Now we could of course written it in an until loop, and it really is our own choice whether we use until or while. Sometimes it's more logical to use one than the other, but if we look at this, if we go through until x has a value of 0, we can go through and close off our test, end that line, go through into our do loop, and of course then we can start by echoing out the current value, and obviously we're starting on 11 this time, and then we can go in and decrement or decrease. So let's make sure we've got x equals, so x equals x minus 1. So that's then making sure that we count backwards. So we're going to start on 11 and we're going to stop when we get to 0. But with that done, we can go through and correctly end this line with a semicolon, add in that magical done keyword, hit the big enter key, and there we go. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There you go. I can count backwards as well as forwards. But we've been able to see that we can utilize both the while and the until loop. And again, it's just a matter of choosing the one that suits our logical way of thinking to get something that works for us. Now, these type of loops do work well where we have an incrementing or decrementing value, so we can see them working well here. But of course, there are many other different types of loops, and we're going to be taking a look at our for loop in the next clip. Now, going hand in hand with our while and until loops, we have for loops. For loops are generally designed so they can iterate over a list. The list itself might be generated manually, where we go through and create a list and we iterate through each item in the list, or the list might be generated from a command. So, yeah, listing a directory or something similar to that. Now there's not just one style of for loops, we've got different for loops to take a look at. The first we're going to investigate is the C style loop. As we go through, of course, we're starting with our keyword for, and then we open up our double parentheses. Now this isn't a test, just the way the C style loop is written. It has three expressions. The first expression is to initiate the variable. Here we're just calling the variable I, and we're initiating it with a value of 0. As we continue separating the expressions with a semicolon, we're then looking at our testing of a condition. Here we're looking for the variable being less than 5. Whilst it is less than 5, we can then go through and continuing iterating. The third expression then is looking at incrementing or decrementing. Plus plus is adding to the variable, minus minus would be taking away or decrementing the variable. We get into our looping structure with our do block. Here we're just echoing out the variable, and then we're finished with the done keyword. As we then continue, we can also see that this could be written on a single line. Here, though, we're just reversing it a little bit. We're going through taking a look at I being set now to a value of 5, and we keep looping round whilst I is greater than 0. But of course we've got to count backwards now to get to 0, so it's I minus minus. So we can write it either way, and in some ways we can represent our while and until loops using this for loop. The list itself now is being generated by our variable. Another way, of course, of iterating through a list is by using an array. So if we go through and remind ourselves using the declare minus lowercase a, we can go through and set up an array where we use an index. Uppercase A would be our associative array. So we can set up then the values Bob, Joe and Sue. Here we can go through and look at how we can count the elements. So this would say that we've got 3 elements. Now putting this together, we can start at I being a value of 0, so starting at index 0. We can then continuing whilst we're less than the number of elements. We can then go through and increment our variable. We're using I for index here, so it does kind of make sense, the variable name that we're using. As we go through, we can then go through and create a user, so sudo and user add, choosing then our user from the correct index of our array, so $I. If we take a look at the classic for loop that we would have within our bash or Z shell, we can then go through and do something really simple like this. For f being a variable perhaps representing a file, in, and then we can go through and look at the output of the ls command. So we could use it like this where we're running the ls command, but we could also use it dropping the dollar symbol, we wouldn't need that, and just have a list being star. That then is looking for all files. So it makes more sense, I think, to use the command, but there is a shortcut that we could use, so dropping the dollar symbol and just having the star inside of our parentheses. We then go into our block and we're going to then run a stat command against that element, and we're going to go through the %n is showing the name, and %f is going to show our file type. And of course we're working on our $f, our file that we're currently working with. Now, like always, looking at slides is one thing, but we're going to get a lot more understanding and practice by working directly at the command line to see how we can work with these different styles of for loops. Now, as promised, we're going to get busy on the command line, and we're going to take a look at the demonstrations where we can see the different styles of for loops that we can create and how we can best manage our for loops. As I say, this is a demonstration, and the best experience that you're going to get is hands-on experience, so play along too. Now, the reality is there's no need to replay exactly what we've seen within the slides. The slides give you one example. Perhaps it's going to be better if we work with a different example. So let's go through and create ourselves a directory. So if I go through and do mukdir and then let's say play, we can go cd and escape and dot. Escape and dot will bring up the last argument, so brings up play, so makes it a very simple way we can get into that play directory. Obviously, looking there, we don't have anything. We're going to create a few files. Now, obviously, there are different ways that we can do this, even directly from looking at ranges within Bash, but we're going to use a for loop. So if we do something like for, and then go through and open up our double parentheses, so this is then different to the advanced test that we'll be looking at with our arithmetic operations. This is just our classic C style. So if I go through now and then have my variable I equals, we might start on 1. Our second expression, and we separate the expressions by using that semicolon, we can then go through and say, well, whilst our variable I is less than 10. So if we're saying less than 10, when we get to 10, that's no longer less than 10. So we're going to be working then from 1 through to 9. And then we want to make sure that we increment, so I plus plus. We close off our double parentheses, and we don't need to worry about the extra spaces here. We don't need the spaces inside of the parentheses. We can then go into our do block, so semicolon and do. And then what we can do here is maybe then touch, and we can have then file and just call it $I after it. So that's going to be file 1, file 2, and so on. Now, when we look at this, we think, okay, it's simple enough. But even for some very simple usage, if we want to show the difference, let's say, between a FAT16 and a FAT32 file system, it's really the number of files that can be created in any directory. So we can then go through and create 128 files very quickly to show the limit that we might have within a FAT16 file system. So as we then go through, we finished on this, we can hit our done. And now when I look, we've got file 1 through to file 9. Well, I suppose now we really need to look at deleting them. So I'm going to up arrow key. If we then start on 9, that's our upper limit, we can then go through and say whilst I is greater than 0, and we want to decrement. And then, of course, we want to delete that file. So then RM, and then away we go. Again, we don't see any output, but we would have deleted then all of those files. So if I look at listing this, we can see now those files have been deleted. So we created the files 1 through to 9, and then we deleted them 9 through to 1. So again, just looking at different ways that we can manage this. Now, another way that we can create a list is by creating an array. So if I go through and create, declare minus lowercase a, recall, if you remember, that the lowercase a is an indexed array. So we use index 0, index 1, index 2, and so forth. If we use the uppercase A, that would be an associative array, where we have things like name equals Bob, age equals 55, where we then have these key and value pairs. So an indexed array will work for me well. We can go through and say users, and then our assignment operator, and open up our list. We can then go through and say that we can have then Bob, we can then have, let's say, Sue, and we can have the user Jake if we want. It doesn't really matter. But there you go, we've got a list. If we go through and hit enter, that's the array created. If we look at declare minus P and then users, we can then go through and see that this is, as we said, an indexed array. So we've got the values Bob, Sue, and Jake, and the index values 0, 1, and 2. Now, one of the things that we're looking at, and the syntax isn't necessarily the most fun, but we can go through and work out how many elements we have within our array. As we go through, if we use echo, we just want to print it to our screen. We can then go through and look at $, and then just use the delimiter of our brace brackets, and we're going to go through and put in our count, so the pound or hash symbol, users, and we want to look at all elements or all indices, and then close off our brace brackets. So when we look at that, we've got 3 elements. So this is really the length of our array. Now we could feed this into a separate variable if we wanted to, but we can use it directly like this. So we're going to see that then if we go through for and then open up our C-style structure, I equals 0. Here it is important that we start on 0 because we want to start on Bob, so index 0. We're going to be using this variable I for our index. We can separate out our expressions with the semicolon as we saw before, and we can say, well, whilst our index is less than 3. So I'm not going to hard code this to 3. We're going to use then that expression, so we could use this even if we had more elements within our array. So we're going to go through and use our dollar brace brackets, go through and put our hash users, open up then our square brackets, and we want all indices, close everything off. So it's a little untidy, I know, but again, we need to get used to it. We need this hands-on practice. We have to suffer for you to gain the knowledge. Anyway, now that you've suffered a little bit, we can do something really easy. We can increment, so I++. Close off our double parentheses. That's the end of our line, so a semicolon, and then we can continue into our do block. Now again, we won't worry about creating our users, but we could create our users. All we're going to do is echo out then, and we go into our dollar. Because we're going to use the index value, we're going to go through and put our users inside of our delimiters. So this then is great when we need to work out exactly what we're talking about. And we can go through and put our index number, and that's going to be our variable $I. Close off then our brace delimiters, and we're just about done on that. So that's the end of a line, and then done. So what we should see now is each of those usernames being printed out. But obviously we could use that to do other tasks. Again, it's just giving you the idea. Now, of course, we don't have anything in the directory at the moment, but if we go through and let's do like a mkdir, and we can have it as like a dir1 touch, and then we can have, let's say, file1. We can have, let's say, file2. If we really want to, let's go back and create ourselves another directory. So as we then go through and list, we've got those 4 files. Now, of course, the listing is okay, but if we wanted a little bit more information, we could use the stat command. So if I did stat, let's say, file1, we can see then that we get the information about file1, but very detailed information. If we go through then and just look at -c and choose, let's say, %F, we can see then the file type. If we use %N, we get its name. So we can start combining some of these switches together to get a more detailed output, but not quite as detailed as everything. So let's clear our screen. Look at how we can do this with our for loop. So if we do for, and let's call the variable file, in the slides it was just called f, but we can use a complete word if we want, in, and then the output of our ls command. We can then go through and run our block, so do and then stat. We want then to do the -c, and we're going to include then our %name, so we want the file name, but we also then want our % and file type to be printed out. We're working on then our $file variable. That's the end of a line. We can go through then and finish our loop. And we can see now that we get the output in the way that we've specified. Now, again, I'm not saying this is brilliant, but it starts giving you some ways of looking at you can format output from commands using a loop. So hopefully this has given you some ideas, but don't worry, we're still not finished with more looping structures to look at. Now within a loop, we've got a couple of extra keywords that we can use to control the flow: continue and break. Now when we use the continue keyword, we can test for a condition, and maybe if that condition is met, we can ignore the current element and process the next element in the iteration. Whereas with break, we will exit the loop completely. We can see this where perhaps we want to be able to list files but not directories. So again, we can use the same structure as we looked at before, building in then our if statement. If it's a directory, then we continue, so we don't process the current entry, but we continue with the next, end our if statement, and then we can echo out the file variable that we're working on. But then we should be only listing files and not directories. Come on, let's move out to our command line and see how we can work with these extra elements. Now, as we saw before, we can list everything out, but we can build into this our tests. So we can go through, and after our do loop, we can continue here and build in our if statement. So here we can then go through and specify if, put in our condition that we want to test for, and we can go through and use the advanced test -d, and then go through and take a look at what we are looking at. So that's going to be $file. If that is correct, then we can continue. And you have to be careful reading this, because we don't continue processing that entry, we continue with the next entry, ignoring the current entry. So if our current entry is a directory, we ignore that and then process the following entry. Now when we go through, we can end our if statement. That becomes an end of the line, and then we're into our stat command. So now as we go through a look, we can see that we're only seeing our files. We're not seeing our directories. We can also go through and change this. Let's go through and change this to only process directories. So if we go through and look at it being a file, we only see our directories. If we went through and took a look at what would happen if we used the break keyword, then as soon as we hit a file, then we don't process anything else in the loop. Now this way we're not actually getting any differences, because the directories are processed first. But if I go through then and take a look at the directories, then we can see that we hit the directories first. As soon as we hit a directory, we completely leave the loop, so we get nothing being printed out. So break leaves the loop completely, whereas continue just ignores the current entry, carrying on or continuing with the next entry. Now so far we've been looking at the BASH and ZSH shell, but everything we've done so far has been from the BASH shell, because we could use either shell. The for each keyword is only available to us in the ZSH shell and is not available to us within the BASH shell. So with this then we're going to have to fire up the ZSH shell. Now the for each loop forgoes the in keyword, and we don't need the do starting our code block. And instead of using the word done, we use the word n. So we can go through then and look at for each f, and then just go through and look at our items. We can then echo out the variable, and then we can use the keyword end. So come on, we know what we're going to do. We're going to dive out, take a look at the Z shell and the for each loop. If I look for the keyword for each, it's just not tab completing. It doesn't exist. So I'm in the BASH shell, but let's fire up our ZSH shell. So we already installed this much earlier on in the introduction to this course, so we have got the ZSH shell. The ZSH shell is available whether you're using Ubuntu or whether you're using distributions such as CentOS. It's going to be available to you. Now that we've got it installed and now we're running the ZSH shell, when we look at the for each keyword, we have got it. So if I do for each and then go through and we'll just call it F in then our list, and we don't need to use the in keyword, I can just hit enter. We don't need the start of our looping structure, and we can see that we get a more detailed continuation prompt. As we then go through and we can echo out our $F, and then we use the N keyword to end the block, and we get our listing. So in some ways this becomes a simpler format, and certainly when we're looking at the Z shell, we get other advantages like the continuation prompt that we're looking at now just is a little bit more tidy. Now what we're going to do now is that we're really going to put a lot of things that we've looked at throughout the course together. So we're going to be looking predominantly at creating menus, but we're going to be using loops, functions, and case statements. Now here we are then back on our command line and back in our bash shell, and we're in that play directory. When we run a listing, then we've just got those couple of directories that we had created and a couple of files. It doesn't really matter what you have there, but we're going to go through and create ourselves a new little script. So menu.sh. With that done, we can go into insert, and we're going to go through then and make sure that we add in our shebang. So we're going to run with our bash shell, although again we could run this with our Z shell if we wanted to. Now we want to look at pretty much a lot of the things that we've gone through. So if we go through and create ourselves a function, we can call this, let's say, create_directory. We can go through and perhaps prompt for a directory name, and once we've got the directory name, we can then go through and create the directory. So there's the start of our function. The first thing that we're going to do is make sure that the directory is created in lowercase. So we're defining this as a lowercase variable. When we use declare within a function, it automatically becomes a local variable as well. So we know that this function then will be standalone and not spilling anything out to the calling script. We can then go through and create a variable. We just call it directory. As long as that's not being used elsewhere, we're going to be fine. With that done, we can then go through and make sure that we prompt a little bit, so we can go through and echo out as we've seen before. Or we could do something like this, go directly into our read command. If we go through and put read -p, then that becomes our prompt. So enter a directory name. So just a different way of doing it and condensing our code a little bit. We want to read this into our variable directory. Now that we've done that, we can go through and run our muckdir and then whatever we have within our directory variable. Now all of this, remember, was in our function, so make sure we go through and close off our function. Encapsulating our code inside this function here really does make a lot of sense, because we're only going to have the one line create directory that's being called from the case statement that we're going to use for the menu. Now we also want to look at our looping structures, and we can do something like this, while true. Now this true is always going to be true, so we're going to loop continuously, but we do want this, believe me. We can go into our do loop, and the first thing that we're going to do is clear the screen. We want to make sure then that we move the menu to the top of the screen every time we've finished. The menu itself we're going to create with some echo statements. We can echo out a little bit of a prompt first, so we can go through and display something like choose from the selection below, or whatever text that you choose to display. So we're going to say choose 1, 2, or 3. And then we're going to display what these choices actually mean. So our menu continues by using echo again. And then, of course, we need to explain what number 1 does. So 1 then perhaps can be used to list or display logged in users. So list users or something like that. We can then go through and echo out. Item 2 then might call our create directory function. So we can then go through and say, well, if you choose 2, it's going to be creating a directory. We're going to be choosing 1, 2, or 3, and we can have 3 representing then leaving or quitting the menu. So this is how we can leave our looping structure. We can then go through and read. We've already told our users we've got a prompt, so choose 1, 2, or 3. So we can go read. We don't have to display that information to the screen, so -s is to don't display it to the screen, be silent. we're only accepting one character, so minus n1, saying that we only accept one character. It's going to be 1, 2, or 3. So we're reading in. We haven't specified the variable. If we don't specify the variable, then what's going to happen is that it will read into the variable $reply. So we can go through then and look in our variable $reply. It's always a good idea, where possible, to quote our variables, just in case we've got spaces in them. In this case, we can't because we're only accepting one characters, but again, it's a good idea to get into the habit of doing so. A case statement then is going to be look in a list of different options, and we can then go through and start specifying, well, if it's option number 1, then we can go through and list our users, so that's going to be our who command. Now, we've already put on the screen that if we choose selection 2, we'll be creating a directory. So this is where we can then make reference and call our function create underscore directory that we had created earlier. So this will then go through and execute our function and, of course, prompt for the directory name that we want to create. So if we put in our function, and then don't forget to end that with a double semicolon, and we can then go through and specify that if it's 3, so this was to quit, then we can use our exit command to leave our script. So that's how we jump out of our while loop. And then we can go through and end our tour of the case statement. Now we want to make sure then that we have the ability to see the output. So if we've listed our users, of course, we want to be able to see the users that we've listed. If we want to see the create directory, we want to see any output from that. Now, if we don't, we just loop round and we don't actually see what's happening. So what we can do is read minus n1, again, just accepting one character, put in our prompt, and then press any key to continue or whatever. So at least this way we pause until we hit a key to continue. We're then finished with our loop. So you can see the first thing we do within our while loop is clear the screen. We then display our menu, we read the selection, and then we display the result. So the who command, the create directory function, or exiting. So let's go through and see then if this works. Let's go through and save this, chmod, and we can go through and put u plus x for our menu. Now as we go through and run our menu, we can see now that we've cleared the screen and we've gone into our looping structure. But we've got to select something. So again, our loop is controlled a little bit here. When we go through to list our users, well, only Tux is logged in. But you can see why we've got to have this press any key. Otherwise, we would have gone back into our loop and we would have cleared the screen. Let's go through now and create our directory. We can call it, let's say, and then let's say mine. So this is all in mixed case. Now, as we go through, we will have created that directory. Let's quit out so we can check it and then run the ls command. And we can go through and see that dir mine now is all in lowercase. So the minus L for our declare has been working. So hopefully you found this really useful. But let's go through and recap a little on what we've seen. Now here we are, the end of another module, and in fact, the end of this course. So well done, you've done an amazing job to get this far. Thank you so much for the effort that you've put in. As we looked at this module, we've seen loops. A while loop will loop while a condition is true. Whereas when we look at an until loop, it will loop until a condition becomes true. So an important differentiation there between the while and until loop. When we look at our for loops, they're a different style. Here we're looking at our C style loop, and we've got these three expressions: setting our variable, testing our variable, and incrementing or decrementing the variable. The keywords do and done surround the actions that we want to complete during the iteration. Now, as well as the C-style loop, we've got our classic for loops. And in the bash shell, we can go through and write a classic loop something like this for I, in, and then our list. So here we've got a range 1 through to 5, and then of course our block of code again. Now if we're working with the Z shell, we have the for each keyword. Again, if we want to go through that same range, but as well as having the brace brackets, we put the parentheses around the range. We don't use the do keyword, that's not required, and we use end as a replacement for the done keyword. Now we have these keywords as well, continue, to control our loops. With continue, we ignore the current iteration and continue with the next, whereas the break keyword will leave the loop entirely. But that's it, we've reached the end, and again I must extend my absolute gratitude for your efforts during this course. So until the next time, au revoir, and I'll see you soon.